look at the questions where we have a push down automata. And in this push down automata, we have defined certain rules. For example, this is the first question where the word is even and word is consistent of A and B, meaning that the length of the word is even. For example, A, B, A, B, A, B, but it's even, right? 1, 2, 3, 4, 5, 6. These are 6 letters. How do we try to follow this? First of all, we read a A from the word. For example, this is our example word. Let's try to run this on the stack. Read a A, read a A, read a A, read a A from the word. Read whatever you read from the stack. So first of all, our stack should have this. So read a, whatever you read from the stack, put it back and put X on the stack. Read a B from the word, whatever is on the stack, put it back and put a X on the stack. Now we can take this empty transition to here. Let's just say, oh, whatever is on the word, whatever is on that stack, put it back and go here. And in this state, when you read a, you can transit to the next state. Once you can do it in your head. Okay, I read 2 words, it's even, of course. So when you read half of it, you use half of it to push X's and the half of it to pop that X's that you pushed. So you, in this non-deterministic situation, you can always move whenever you want, but you can think of in your head that only one way there is to you to read the word. Then you go to the new state and you say we have a rule A. If you read a here, we read a, whatever is on the stack, pop it. You read a B, whatever is on the stack, pop it. And then we have a rule for this symbol that if that's there, whatever is on the stack, sorry, it should be if you read nothing in the word and there is this symbol on the stack, then pop it or make it nothing. Now, word of A is even, meaning that the A's in the word are even, the B's are not. So for that, you will read a, we will put a, or whatever is on the stack, we put a. If there is a B, whatever is on the stack, put nothing. So what we do here is that because we know that A is even, B we don't care about. We don't care about the B's. Only A's are even. So what we do is that we say, okay, we read a, we on the word, we read it, we push a, we read a B, it doesn't matter. We read another A, we push another A, then we change the state once we're done with the A's. Then we have rule for B. If we read a B, put what's on the stack back on the stack. If you read another B, do the same. If you read another B, do the same. So actually what happens is that the moment you read the first A, I think I made a mistake in being able to read it properly. A, B, B, B. The moment you read the first A, you just change the state. You push a, and then because whenever it's even, you divide it by 2. So how many did you read? 1. What is the half of it? It's 2. If it was 4, for example, if it was 1, 2, 3, 4, then half of it is 2. So you read 2 A's and then you translate to the next state, and then you pop those A's and B remain unchanged and the stack remains empty. So but now we have 1, 2, 3. So you push a and then you just go to the new state and you pop that using this rule. And once you do that, then you have read both of these, then you have B's remaining, the stack is empty. You can keep reading B and put it back on the stack. This rule you can keep repeating, and then you have read the whole word. And the moment you read this, the word is empty, you read this on the stack, you make it empty, and then the stack is fully empty. You have read the word successfully. Then you have a palindrome. A palindrome is empty the other way, right? So for example, A, B, and then B and B, C. So these two are the same, these two are the same, this middle one could be different because it's an odd palindrome. Now what we do is that the first half, A, B, and C, based on that we have grouped them into two categories. Like it's the first group should have, because it's an odd palindrome, it should have more than one. So this is the first group. Just like we divide two strings and then we transition to the next state in even ones, it's an equal half. But in the odd one, you take the first half is a little bit more than that. And initially our stack had this. We need to read the word, this one, for example. We say, okay, read a A, put a A. Read a B, put a B. But if you read this B, this is where you have to do that, because this is, you need to know the middle word. This is the middle one, right, in your head. This is the even exact length. This is the extra odd that makes it an odd. Then you, to read this one, you take this transition. You say, okay, whatever is on the word, whatever is on the stack, just erase it. Sorry, after reading the word B, after you read the B, this B, then you say, okay, then you translate. After doing this, you say, okay, whatever is on the stack, whatever is on the word, whatever is on the stack, erase it and go to this state. Once you come here, then you say, okay, if I read a B, I will erase it. And if I read an A, whatever is on the stack, erase it. And if the word is empty, just like it is empty now, we read everything. If you see this, then empty it. That's how you do it for the palindrome. Now here we have A of J, B to J, meaning that number of B's are 2 times the number of J's, meaning A, B, 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 B. So A's are 2 times, like two times multiplied. So now what happens is that when we write a, we write A, one time, then A, 2 times, we read it. Now we change the state, whatever is on the stack, whatever is on here, replace it and go here. When you read a B in the word, whatever is on the stack, just replace it, or empty it. Whatever is on the stack, empty it. Whatever is on the stack, empty it. Whatever is on the stack, empty it. And if you read nothing, and if you read this, then empty it. That seemed quite easy, I think. Now it says A of I, B of J, and C of K, where I plus J equals to K. Meaning that A and B's are the same amount of C's. For example, the amount of A's and B's equal the amount of C. For example, if it's 3, then this is also 3. Like 1 A, 2 B's, and then we should have 3 C's afterwards. So based on that, what we can do is that we read a, we push a, we read a B, we push a B, we read another B, we push a B. We try to group them in 2 ways. So for example, this is equal to this one. So pushing, popping. We just categorize them the same way. Whatever we can also say X here and X here. Meaning that we just break them into 2 parts. Where we use the first part that is equal to the second one. The first part will only be used to push and the second one will only be used to pop. So when we push all of these, then we just seed an empty transition. And we try to pop all of these C's with this, just like this, and then we have read the word. Now we have A of I, B of J, and C of K, where I equals to J, meaning B is equal to C, A is equal to B, and B is equal to C. Now here we know the amount of C's don't matter, so C can be ignored. A and B are equal, they can be popped, and in C we just don't do anything. And B of C, so we can pop B on the basis of C, And A here we can ignore, meaning that we can say, okay, A, you read a A, put a A, just go there. You read a B, you pop it. If you see a C, just ignore it, read it, and just ignore it. Then we will just read it. Then we have made something similar like this. This is the final transition, because we make two paths for both of them. One that goes for the A path, one that goes for the where we ignore the C's, and where we ignore the A's. For example, here we ignore the C's, here we ignore the A's. The other one, here we ignore the A's. So let's try to do A equals to B, and C we ignore. So if you read this word, where now what happens is that you read a A, it doesn't matter what's on the stack, you put A there. You read another A, because there are two A's, then you go empty and you go reading B. The moment you read a B, you remove an A, you remove another A, and for C, whatever was on the stack, you put it back, and then you also read C. So basically, A is dependent on B, and for C, we just have an empty rule, where C, if you read C, whatever is on the stack, whatever is on the word, put it back. Meaning you just have an empty transition there somehow. And that's the same thing when we have to ignore the number of A's. For the number of A's, if you read a A, whatever was on the stack, whatever is on the word, just put it back, and then you have read it. Then we continue to B. For B, you read the word, whatever is here, you put it back, and then you put a B here, you put a B here, then you go there and you pop it based on the number of B's you pop, and then on the C's that you're reading. Then you're done. Then a question appears that what happens if A of I, B of I, and C of I were the same? What's the problem that happens? The problem is that we cannot really solve this, because it needs to depend on something. This depends on this depends on that. But in this way, all of them are equal. So a push-down automata with two stacks cannot really solve this. That was the final question after this one.